Okay, welcome to today's video where we're going to talk about these little CH341 Alpha EEprom programmers. Pretty cheap little guys. You get off you can spend all the way up to $15 to get one off of Amazon, or you can go order one from AliExpress for about $2. So I'm sure these are made in a labor-friendly work environment. I mean, how do they keep it so cheap? It has a ZIF socket, and other than that, it's really simple. It's pretty cheap, but it comes with some accessories too. So we'll look at the accessories here in a minute. But what the video is going to be about is the CH341 Alpha, and we're going to go over how it works, how to get it installed on the computer, because firmware is a little bit weird, as you'd expect for something so cheap. And then after we get it set up, we'll go into and practical application of it, and then after we do a practical application of it, we'll get into a little bit of how it works. We'll take a look at the schematic and stuff, because the schematic's open source to it. But the reason why we're doing a video about this little cheap guy, if you're familiar with the channel, I made an EEprom programmer to use to do in-circuit programming on the like 99 to 2007 GM stuff. I mean, you can edit the code and then do some of the newer stuff too, because it's just more read-write cycles for that. But yeah, so I made this guy, but buying this is cheaper than making this, because this thing costs about the same amount as this Arduino Nano, and then you still gotta get the circuit board made, then you gotta source the components, put them on there. So this is a better option. It's a better option, it's off the shelf, and it works. So that's why we're doing a video on this. Because if you're familiar with these Mini Pro EEprom programmers, they will not work in circuit on these GM things. Even if you have the one with the in-circuit programmer, it still does overcurrent protection. You can go in there and modify it, basically short out the circuit, the shunt and its capacitor and all that. That allows it to tell how much current's passing through. But I mean, I don't want to take this thing apart and modify it. And this right here is less than $5. This thing right here, $80. So like go in and modify an $80 programmer. I mean, I've had mine for a long time now. I've had mine since like 2010. I'm sure they've gone down in price since then. I'm gonna guess you can get one for like $30. I'm not gonna do any research. I'm not gonna look into it, but I'm sure you can get one cheaper now than when I got mine. But yeah, we're not gonna go modify that to be able to do something that we can just do with this $5 guy. By the way, you can still use this in circuit on Linux. The Linux driver ignores the overcurrent protection in here, so this will work if you use it on Linux. Just a heads up. But I'm using Windows 10. I like to do work on my computer, not work on my computer. So I used to be a diehard Linux user. Don't get me wrong. I think Linux is a great option, just not when you're trying to be productive. So yeah. So we're going to replace this guy. I'm still going to leave my videos up because it's still fun content, and it's a good learning experience to put one of these together. You get to learn a little bit about SPI and all of that. So stuff's still going to be out there. The Gerber files will still be on my GitHub if you want to make one of these. But I don't recommend you going out trying to make that anymore. Well, you can just buy this thing so cheap. I mean, yeah. The factory that makes these probably are not under the best working conditions. I don't even understand how they make money off of it. It's so cheap. But yeah, let's get into this. Let's switch the camera down. We'll take a look at everything that comes with it, and then we'll wire it up and do some stuff with it. All right, so let's take a look at what you get when you order this. So you end up getting your programmer right here, a 200 mil to 2.9 mil, 200.9 mil. SOIC 4-pin adapter. If you pay the extra like dollar for the 1.8 volt adapter, you get it. If you don't get it. And then you get a adapter for using one of these clips, so it just goes to that DIP 8 to this header here, and then obviously the clip too. Now I'm not a fan of these kind of clips. I really hate them. I find them pretty useless. I have one right here that I keep having to sand it down more and more over time. So they push out a little bit there as you use them, so you have to keep pushing the darn things back in there. but still the pins themselves start to wear out, and I don't know. I haven't had much success with these. I don't like the clips, these cheap clips. There are some bed of nail ones, but they're really expensive. So you can get like a super cheap one that's just the epoxy and some wires coming out. That's $25, and they have like these nice like handheld pin ones that are they're around $100 for one of those. So maybe we'll do a 3D printing project here in the near future to make a handheld bed of nails for doing this kind of stuff. But my preference is just using one of these. This adapter doesn't come in this one, but this is the 150 mil. Like I said, it comes with a 200 mil. You need the 150 mil SOP 8 or SOIC 8 adapter to properly fit those EEproms that you guys that are viewers of this channel would be using. I mean, this may be great for BIOS chips. I don't know. I don't do that stuff. But if you're getting this thing to program BIOS, I imagine it comes with everything you need right here. Not something I do. I'm using this in an automotive application, but there are other people that will view this video that are using it for a different application. And I would just say check to make sure your chip that you want to use is supported before buying this. And you can't beat the price on it. It's literally one of those things that this one's not good just because of the price. Like it's not like it's cheap garbage that sometimes works. I mean, it seems to work pretty reliably, and that I would say the only con is there's no housing to this at all. There's just literally nothing here stopping you from setting this down on your metal workbench and just shorting all the pins together and frying your USB port. So we have a 0 ohm resistor, which I'm guessing they are using as a fuse, but yeah, that's not a fuse. So there is no fuse on here to protect your USB port on your computer. So if you do short this thing out, it is going to kill your USB port. So yeah, maybe we'll do a future 3D printing project here where we make a little clamshell for it. Probably just have it kind of pull down right there. Just do 2 little screws in a clamshell, and then it'd just be open up right here. Just have this whole section here open, so that way you still have access to these headers and the ZIF socket. So we would need at least this much open here. But that's ideas for future videos. May or may not actually happen. We will see. So yeah, I think it's a pretty good. It's a pretty decent package for the price. Again, like I said, paying like $5 for this thing, and you're getting all of this. Like who's gonna complain about that? And it works. Not only that, it works because of its dead simplicity, and we'll get into that at the end of the video. But let's set up the software now and take a look at it on the computer and just see exactly what all we have to do to get this thing up and running. Okay, so let's find us the correct driver for this. So just go to Google, search CH341 alpha, and you'll get these results. You need to go to this one, the onetransistor.eu, and it's got you all the different links that you're going to need to do. And it's got you the schematic and everything useful you'd need to know about this thing. So for the drivers, just scroll down to drivers and tools, and it's going to take you to the Chinese website that makes these. So you need both the serial and parallel drivers for it. So you just click that. It's going to take you to this really sketchy Chinese website. It's the driver for this chip. And you just, you can translate it if you want, but this one is the download button. So just click the download button and install them. And you got to install both of them. So just get both of these going, and then you'll be able to plug your stick into the computer and it will recognize it. The next thing you need is as programmer. They got a roundabout way of getting you the link to it. Just get the GitHub for it. So I'll put the link in the description for all of the drivers. So in the description you'll have this link, which is going to take you to it, and you're just going to want this guy right here. You don't need the source code unless you want the source code and want to compile it. So all you have to do. Download that zip folder, extract it, and then once you open it, then you can open the program. And this is what the program looks like. So I don't have it plugged into the computer yet, and so give me just a second. We'll get to the practical use of it here in just a minute. But once you have the software open, you go here and what type of chip are you dealing with? Are you dealing with an SPI chip, which is what most of our GM chips are that we're dealing with? So it'd be SPI and then ST, and then we're looking at the M20. There we go, M920, and there we go. That's it. It puts the size, the page, and SPI command list in there, and that's it. So, and it supports SPI, I2C, and microwire in as programmer. But as programmer supports different hardware. So just because it's supported by this programmer doesn't mean this hardware supports it. So just be aware of that. That some of the supported ICs may not be supported by this piece of hardware. You may have to deal with the USB, ASP, or the AVR setup. So just be aware that this software is for more than one piece of hardware. But for what we're using it for on this channel, it supports everything we need supported at the moment. Maybe as the channel grows and we start putting different instrument clusters in here, we may need some different programmers, but this will get the job done. And again, this is for a hardware level of doing it. This isn't, you're not going to be able to go into your GM Class 2 or CAN bus, obviously. I mean, this should be obvious without saying, but I just want to state it for viewers that are confused about what we're doing here. So this isn't one of those like OBD stars where you just plug in the OBD port and do it. We're gonna have to take it apart and actually touch the IC for this to do the work that you want to do. So if you're looking for a Class 2 tool, this is not it. So let's actually move on and get into the practical portion of this thing and get it clipped onto a instrument cluster and see if we can read the chip. Alright, so now you have installed your drivers on your computer and you've opened your folder. The folder is nothing to install in it. You just open it and it's already compiled and works. So right now I just have it set on 3.3 volts. So let's put the 5 volt clip on here. So this 3.3, I gotta move this off. The 3.3 and 5 jumpers right here. You can actually program these EEproms at 3.3 volts. They'll work from 2.5 volts to 5 volts. But since there's other stuff on the line, we don't want it dropping the voltage too low while we're programming. So let's get that back on there. So SPI is the bottom one. So SPI, pin 1 is towards the top. So there we go. Now we got it set up with our clip on here, and we're running at 5 volts. We just put a jumper there. We'll get into why this jumper works here in a little bit. We'll look at the schematic, but let's go ahead and put the clip on. So we're just programming this guy right here. All right, so we have it clipped together now. Let's open up the software, choose the correct thing. So SPI. And then ST, and then we're dealing with a STM9520. And then we're going to just do a read back, and there we go. So we've clipped on there correctly. We know we got a good read back because we can see the VIN number off of this EEprom. So it reads back correctly. Now, I'm not going to hold your hand in this video and show you how to do odometer correction because I've been getting a ton of questions about it that are pretty obvious that people are not doing the correct thing and that they're trying to roll back odometers just to roll back odometers. So, okay, so now that we've successfully read from the chip, let's go ahead and write to it. So let's just change this VIN let's just change it to 700. All right, so now we've changed it. We're going to program IC, begin program. All right, it's done programming it. Let's read it back and see and verify. Yes, in fact, we did change the VIN number on there. So this was a success and took all of 2 seconds and was very simple to do. No crazy setup here. So again, you just got your clip, the adapter to the clip, and we're going to set it to 5 volts. We don't have to set it to 5 volts, but we're going to set it to 5 volts. Just for the fact that there is other stuff. This 5 volt rail on here is shared with other things So that 3.3 volts could get pulled down lower than 5 volts potentially. So we're going to leave it off. But I will show you real quick that it will work as 3 volts. So let me take this jumper off. Alright, I got the jumper off. Let me get this set back up on there. Alright, and let's read it. See, we were able to read it. And we'll go ahead and write again to it. We'll change the vid now to 800 and program. Alright, it's done programming it. Let's read it back. Oh, we lost connection. We probably didn't get a good... there we go. We've connected to it again. It did successfully write to it, though. So, it wasn't an issue. We just lost connection there. So, I'm not a fan of these clips, and that's exactly why I'm not a fan of these clips. They lose connection all the time. So, there we go. So, yeah, I'm not a huge fan of these clips. They work okay, but you lose connection sometimes. So, and yeah, you can read and write it at 3.3 volts, but all what you have to do, put a little jumper on there, and you got 5 volts. So, no modifications needed. It works straight out of the box. And I'm talking about this because there's a video that says you do have to modify these, and that video is just incorrect. So, we'll take a look at maybe I'll steal some footage from his video. Let's take a look. Okay, so here's the video I was talking about. We're gonna ignore the first like 5.5 minutes of the video because that's talking about doing a modification to one of these guys for a different chip that we're not dealing with in this one. So I can't verify what needed to be done for that. From what he showed, it made sense. It looked like some of the like chip selects were in the wrong spot and stuff like that. But this portion makes absolutely no sense. Pretty much shows in the video that it makes no sense. But we'll after we watch this video, we'll check out the actual schematic here and see what you really need to do to get 5 volts. Although I've already showed you, you just put a jumper on there. But let's just watch it because this video has way more views than any of my videos will ever get. Yeah, it's from earlier, from about a year ago now. So yeah, let's take a look at it. I did leave a comment down below on this video saying, hey, you don't need to do that. But let's watch
VCC. So when we flip this guy up, this is going to be VCC for the 25, and this is going to be VCC for the 24.
So what he's doing here is showing you that these two pins are tied, which
tied together,
is,
they're not connected to 5 volts.
He's talking about these guys
3.3.
right here, or sorry, I'm holding it upside down. This one right here and that one right there, which are where your 3.3 volts come into
that's
here.
no good. We need 5. So the mod we need to do to the board is we're going to need to cut this 3.3 trace, and we're going to need to jumper a wire from 5 volts and restore the full power that we need to write the chip. I'm going to go make that mod. We'll come back and we'll see if we can get it right. Alright, so here's the 2 modifications on the actual board so that now we can write, because we have to be able to write at 5 volts. First modification is on this 3.3 volt voltage regulator. We're going to lift this middle pin off so that we're no longer outputting that voltage, because we're not going to use it at all anymore. That's modification 1. So you just lift this middle pin. Modification 2 we talked about in the previous sequence. Now we're going to do the bodge wire over here from +5 over to this pin, since we know this pin.
His solution there is to remove a leg of the voltage regulator, or just lift it off the board, and to make a permanent bodge wire to 5 volts. When putting 5 volts on this side of that 3 volt regulator is not going to damage it. You just put 5 volts there. It'll work. So yeah, put 5 volts across it with a jumper, and it'll work. That's the whole point. It's the whole reason why they put a jumper there. Like, did you think they just put the jumper there for their own health? And if you're concerned that, well, maybe the 5 volts is going to damage the main IC here, the actual the CH341. No, it runs on 5 volts. That's how it works. And if that was a concern, well, why would you be lifting the leg off of the 3 volt regulator? Also, that 3 volt regulator, it's the middle pin. The middle pin's not ground. You still had 3 volts when you lifted that leg. So, yeah. There's this is not ground here. Well, let's verify that. But yeah, I believe on the 171s that is.
Actual board.
All
So
right,
that
so I
now
just
we
went
can
back
write
to
it, 'cause we have to
verify.
go to write at 5
He's
volts.
just lifting this pin off
First
because I didn't pick
modification is
this
on
up
this
the first couple of times I
3.3
did. So he's
volt
just lifting this
voltage
pin off, which
regulator. We're
is
going
the
to lift this
output.
middle
I
pin
went and looked
off
it back up,
so that we're
so
no
yeah,
longer
there's a
outputting
cutscene because I went and
that
checked.
voltage,
So
'cause
yeah,
we're not gonna
that's the output of 3.3 volts right there. This is also the output of 3.3 volts right there. So if you lift that leg and leave that on there, you still have 3.3 volts on your rail. So you've done nothing. You've achieved nothing lifting that leg off. You still have 3.3 volts. So yeah, that's not even doing anything there. So yeah, sorry for the weird cutscene, but I had to verify. I had to make sure I wasn't crazy. I got my multimeter out, verified that they are tied together, and I looked at the data sheet. Yeah, these that that why? Why? It's come on now. The three, you're not doing anything. Why did you not check that? I mean, that was simple to check too, because it's the middle pin of any IC like this is always tied to the top, unless it's 4 pins for some reason. I mean, that was obvious. I can't believe I didn't catch this till this is like my 4th time recording this part of the video too. I should have caught this earlier, but yeah. So no need to do that. Don't lift a leg off the board that's not even going to do anything. What are you doing? What are you doing? I don't get it. Oh well. So let's continue on with the video. Let's take a look at this schematic and see if there's anything else we need. But yeah, there's no need to solder a permanent bodge wire on here, and there's definitely no need to lift part of your 3.3 volt rail that's not going to go away from what you just did there. So yeah, I don't know. I have no other explanation. I did not take it off of the board to verify that pad's not connected. That pad, maybe the pad's not connected on the other side. Maybe they didn't tie them together for some reason. If you'd like, I can take it off and see. We can see. So, let's continue. This is the schematic to the to this guy right here. Freely available on the internet. I didn't go steal this or anything. Same place we were talking about earlier. So that's schematic of this guy. We got I2C going on here, and we got SPI going on here, which is what's going on in here. So we know we got the right thing. This is the same IC, and then we have our 5 volt to 3.3 volt regulator here with its normal setup where you got your 2 little capacitors on either side of it. A normal kind of thing going on. So we get our 5 volts from our USB port. Oh, y'all can't see that. So we get our 5 volts from our USB port, makes this 5 volt rail here, and it comes up, and you have resistor and your LED. That's all there is to the power circuit. There's no actual logic there. This chip here runs off of 5 volts, as you can see. So it goes straight there. We get 5 volts, comes down, and it gives us our other header here. So then we have our 5 volts and then our 3.3 volts from that. So if we tie 5 volts there, the only thing that's now getting 5 volts instead of 3.3 volts is the running LED here and our 3.3 volt rail over here. And same with this one too, because they're all tied together. So if we were to do like he did, where solder a bodge wire from here and run our bodge wire over here to pin 7, you effectively get the exact same thing. So it's still connected the rest of the way, so you still get 5 volts to all the other ICs. So you're not doing anything different. So nothing changes. If you watched my last video, I talked about this. I don't get why people still use these traditional crystal oscillators where you have to put the 2 capacitors in there when they now sell I mean, they've been selling them for a while now. The little packages where everything's all in there. It's so much easier. I don't get that. That's a harder way of doing it because you have to read your data sheet and make sure you're getting the right capacitor to go with your crystal oscillator. I mean, it's not that much harder. You just got to read the data sheet. But why not just look and see, oh, does it work at the voltage I want? And just grab that. I don't know. That's me nitpicking on the design here. So, yeah. It's just, there's no need for any permanent soldering work done to the board here. Just use a little header jumper right there, and you're done. Now you got your 3 volts. So if you wanted to use this for any other IC that is not supported by the header here, because you know this header's permanently wired. That's how it's going to be. Like these wires go to those places. So if you want to use this guy to program something that the software supports, but the hardware doesn't support because of its wiring, guess what? Your master in, master out, all of that, it comes down here. It comes down here. So the easiest way to do that would be to use, you could either hook up to the header here, like this, and then you would just need your clip, there we go, and just go into your clip there. You could use these male to female ones, or you can use the female to females. I just don't have any sitting here on the bench. I do have female to female of these. But yeah, it's labeled on the back, so you don't need the schematic here, but we go, okay, I need clock. All right, clock is the second one down. So there we go, we have clock, and then I need clock on, let's just say, pin 1. Let's just say pin 1 is clock. And there you go. That's all there is to it. You're done. This one has solder on it because it's one of the ones that I use for JTAG. So this one's not a good example one, but you know, you get what I'm saying, right, guys? No need to permanently modify anything. I don't need to cut the traces on this and do a permanent modification to it. I don't need to cut the traces on here and do a permanent modification either. Now, this doesn't show it on the schematic, but there is also this if you needed to solder an IC directly to the board. Now, I don't know the pinout of it because it's not listed on here and it's not listed on here. But it does exist if you so choose to do that. So, okay, let's wrap up this really long-winded video. I mean, I've rambled on here for probably 30 minutes now about this little EEprom programmer. I think it's a great product. You know, there's a couple little minor things I'd change. I'd have put a fuse on the USB port. I probably would have done USB micro or USB mini, and I probably would have put some filtering caps on the 5-volt rail. But other than that, it's an excellent design. It's definitely not an engineering tool. It's a hobbyist tool, and it will succeed at that. I think this is a good product. Definitely got to give a thank you to Devious. You guys would know Devious from the 3D printing video because he did all the work on that. He designed everything for the LED bender that we 3D printed. So another thank you to him because he is the one that recommended doing a video on these. I'd seen these things on Amazon a long time ago. I just dismissed them as utter garbage. I was like, there is no way something that is that cheap can actually reliably read these EEproms. And it had terrible reviews at the time because there was like no software that really supported them. They didn't really work back when I saw them. But now there's this good software for them, and he suggested it. He had seen, he'd actually, I'm pretty sure the video that, he was telling me he saw in a video that you had to modify it, and I think he did the modifications to his that we just watched in that previous video. And I'm not picking on Dr. Shock. He clearly knows more than I do, and clearly is better at this whole YouTube thing because he's got a whole lot more viewers than I do. So definitely not picking on him there. Not saying he doesn't know what he's doing at all. That's not what I'm saying. His modification just didn't make sense to me. Maybe he read it on a forum somewhere. I don't know. I don't know where he got the idea for that modification, but it just doesn't make sense. You know, the 3.3 volt regulator is not going to get damaged by 5 volts coming to the 3.3 out on it. That's not going to hurt it. And the other thing, I know I said that, hey, it doesn't make any sense because you still have 3.3 volts. It is completely possible that that pad is no stuff, because I did not take the IC off and look underneath it. It is completely possible that that is no stuff. It that he really is eliminating having 3.3 volts by lifting that one leg. So it's just one of those. It wouldn't make sense for it not to be tied unless an amateur designed the circuit board, which I'm pretty sure an amateur did. I don't think this is a professional design here. I think this is something that a hobbyist designed, put it out on the internet, and then it got picked up in China, which happens all the time. There's all sorts of tools we'll see that were definitely designed by hobbyists, then China picked up and just pushed, like, you're like, oh, there we go, everybody buy this. So it does happen, and that's probably what happened here. But oh, and before I end the video, definitely got to mention, if you guys like automotive electronics repair, and you're a hobbyist, does that kind of thing, or you're a professional technician, consider joining the Facebook group that's down in the description. It's not a Facebook group for fixed until broken video viewers. That's not what it is. It's automotive electronics repair, and I'm not the only moderator of it. We also have Mike and Zach. Zach is the owner of GaugeWorks, and Mike has been a longtime viewer of the channel, and we email back and forth a lot. So definitely consider joining the Facebook group if that's your cup of tea. If you partake in the social medias other than YouTube, because you can't say you're innocent of social media. You're here on YouTube. But yeah, I hope you guys liked the video, and I'll see you guys in the next one.